So hey guys, in this video I will discuss a Leetcode question that is kth largest sum in a binary tree. So what you need to do is, you are given the root of a binary tree and a positive integer k. So here you can see here that the roots of a binary tree means 5, 8, 9, 2, 1, 3, 7. These all are the roots of a binary tree and an integer is given to us that is k. Here you can see here. So then after this, the level sum in the tree is the sum of all the values of the nodes that are on the same level. Means here if you draw a horizontal line, then if you find a horizontal line, the sum of all the values in it called the level sum. Okay. After that, return the kth largest level sum in the tree. What you need to return is the kth largest sum. Here you can see that what is written, the value of the k is 2. So you have to return kth means 2th largest sum. Okay. After that, what is given? If there are fewer than k levels in the tree, means you have not reached to the level to the k, then you have to return the -1 instead of it. Okay. So what you have written here, note that the two nodes are on the same level if they have the same distance from the root. Means the distance from the root should be the same. Means the distance of 8 and 9 is same from the root node. So it is given. So let's just understand. So here is the same example that you have given already. So what is the level sum here? If you draw a horizontal line, means here the sum is 5. After that, what is 8 plus 9? That is 17. Okay, the sum is 17. After that, what is given is 2 plus 1 plus 3 plus 7. That is 3 plus 3, that is 6. 6 plus 7 is 13. Is the sum. And here in the last level, you can see here 6 plus 4 equal to 10. So what you need to find in the question is kth largest sum, and the value of k is 2. Means second largest sum you need to find out. So the highest sum, if you write in ascending order the list of elements, that is 5, after that 10, after that if you write that is 13, and after that if you write that is 17. So here are the elements that you have to get the sum of it. So after that you need to return the second largest element. Okay, so here you can see is 13 is the sum. Okay, so you need to return the 13 as a sum of it. As you can see here, what is written is 13 as output. So what you need to do simply is, here you can see it, what you need to do is simply store the elements in a queue. Why we are using the queue? Because the insertion and the deletion is easy in the queue. Because here you can write is insertion at starting and deletion at starting and deletion at end is easy in queue. That's why I'm using queue here. Okay, in the question you can see here I have used queue in it. So why I'm using, I have already told you, because the insertion at the starting and deletion at the end is easy at queue. And after that, what I will do is simply I'm traversing the loop from I will go from root node to the left side and right side, encounter the sum at each level. What I will do, encounter the sum at the each level and store these elements in an array. What I will do, store the elements in an array, and after that I will see element which is equal to the key. Then I will just simply return that value. Okay, so let's just start our code. It is the simplest code you can ever see. So what is I have written is, firstly I am making the array list that I already told you, because I need to find the sum. I have to find this level, store the sum of the of every level, and that's why I am using array list here. Array list I have stored long here, because here you can see it. It can be of a large value stored in the root node. When you do a sum now, it will get a long value. That's why I am using long here. Okay. And AL is the name of the array list I am taking. After that, new array list. And here I have written long. It is the syntax of writing. Okay. After that, I have used it, create a new queue to store the nodes of a binary tree that I have already told you. I am using queue here. The insertion and deletion at the queue is easy, and after that in queue what I am storing is tree nodes, means the nodes of a tree I am storing here, and that's why I am returning here queue tree node. That's why queue equal to new linked list, because linked list is easy to accommodate. Okay, That's why I'm using linked list. After that, what is q dot add? Because what we need to do is just adding the roots of a tree. That's why I'm using q dot add root. Okay. After that, I have already told you whenever we use the while loop, always need to put the condition inside it. That's why I'm using here q is not empty. Okay. That's why I'm using while q is not empty. After that, what I will do is just I'm using n equals to q dot size. I'm using q dot size because I need to find the size of a q. Okay, I will again tell you in that last why I'm using here, what the reason behind it to find it. Okay, after that I have used long sum long 0. What does it mean is we need to find the sum at each level. Now that's why I'm using the long and 0, initialize at 0, because whenever we do the sum now, if we do a sum with a 0 means, let's just take an example. देखो, if I have the sum, so if I do a sum with a 0 value, suppose I have get the value at 15, so the sum will not change. That is, I will get the sum equal to 15 after also storing the value. So that's why what we need, what purpose used to do, initialize the value of the sum is from 15. Is 0, and initialize the multiplication with always 1, because whenever we do the multiply with 1, we get actual value what we want. That's why always remember that whenever we need to initialize the sum, we always use the 0. Okay, and here I am using long because we need to store the long values here. After that, what I am doing is iterating the nodes, because we need to traverse the nodes now. That's why I am using I equal to 0 to I less than n, and I have already told you that I have used n for q dot size, the size of the q. Okay, that's why I have used it. After that, what I need to do is get the next node in the queue. For getting the next node means q dot hold. As you can have seen my last video, I have already told you the reason behind taking the pole is, again I am telling you, because whenever you are traversing the loop now, you can see here that the root value is going to be changed. First of all, if you are at the first level, the root value is 5. After going to the level 2, you can see here that the root value is now 8, because again and again the value is changing, the root value is changing. That's why I am using q dot move to store the new value. Okay, after that, what I am doing is add the value of the node to the sum. Means if I am traversing now, first of all I have stored the value. After that, what I need to do is just traverse. Whenever we traverse now, we just do a sum of it, because it just given is just do a sum of it. Okay, after that we have done the sum plus node value. After that, what is written? Add the left child to it. So if we are traversing now, we will see that whenever we want to traverse to the left side or right side, whenever we see the node value or the left side is not equal to null, so we will just add it. Simply with the right side, we will just add it. Okay, so q dot add the node dot right. We use the dot operator in Java. Okay, in the C you will see a arrow. In C language you will see a arrow. Okay, after that, what I have just written is the sum. L dot add sum means we will calculate the sum in each case. After that, what I have done is collection dot sort al. Why I have used the sort of al means al is the array, because what I have just sorted down. Suppose I have get the values is 5. After that, suppose I have kept let's just take 50. After that, I have just got 10, and then after 12 I have gotten. Okay, then what I need to do is just sorting of this. That is, I will get 5. After that 10. After that, what I will get 12, and after that I will get 15. So the need of sorting is down is because we need to find the kth largest sum. If we will sort the array now, we will get to know the if we supposed to find the second largest sum now, so just return k minus numster dot length minus k. So what I will get is the 12. Okay, if I want to return the first largest element, so what I will do, just simply returning that is k equal to numster side minus k, and k what is k there? 1. So okay, so simply you can return elements inside it. That's why I am using this. Okay, so collection dot sign, the reason behind it, I hope you will get this. Okay, after that, what is written is al dot size is greater than equal to k. Why I am using this? Because in question what is given to us, that is, if you if there are fewer than k levels in the tree, return -1. Suppose we have to find the Kth largest sum, but we're not getting is because the size of the array is less. Because we have, suppose we have given the find the third largest sum and we have given only 2 elements. So can we find it? No, no. That's why I'm using here what is L dot size is greater than equal to k. It can be equal to k, or after that this return is. Why I'm using L dot get because I want to get that value. I want to return that value. That's why I'm using in Java L dot get is used. That's why I have written al dot get al dot size minus k. I have already told you because we need to find the largest sum now. That's why I am using al dot size. I have already told you that is num step length. Al dot size means the length of the array we have taken. That al dot size minus k to find the sum from the last element. To find the largest element, that's why we need to sort the array first of all. After that, subtract it from the length. Okay. After that, if the condition all not satisfied, just return the -1 condition. Okay. Simply, I am again telling you. First of all, I will run it for your convenience. So just submit it. So here you can see it. It just submit. So let us again explain you for a better convenience what is given to us. So first of all, we need to store the elements of a sum in a horizontal line that the sum in at each level, which is greatest sum, we need to be return it. But means the kth sum. Okay. After that, what is given is array list. I am making the array list because if I got the sum at each level, I will store that in and I will find the sum at the kth largest. Okay. That's why I am using the array list. And then what is written? Create a new queue. Means I am creating a queue. Why I am using the queue here? Because I have already told you because insertion and the first and deletion at the last is easy in the queue. That's why I'm using queue here. After that, I have used tree node. Why I'm using tree node? Because I need to store the values of a tree, the nodes of a tree. That's why I'm using tree node. After that, I'm just simply add the roots. Means I'm just simply adding the all values. After that, what I will do is just simply put a condition that our queue means I have making the list of elements that should not be empty. If it is not empty, just I have first of all I have written the size of the queue. After that, log sum. I have initialized the sum equal to 0 because I need to find the sum at each level. That's why I am using long sum long equal to 0. I am using long here because as you can see here, because we need to find the sum of the large elements, and that's why I am using log here. After that, just iterating the nodes in the current level. What does it mean is just iterating the queue. That's why I am using for loop here. It just initialize with 0 and go till less than n means the size of the array and just incrementing the values I plus plus. After that, what I have done is tree node q dot pull. What I have just told you, what does the mean of pull is, just whenever you traverse the queue, you will find out that the value of root node is getting changed again and again. That's why I'm using q dot pull. After that, what I have done is sum plus node value means I'm just adding the values of a node. That's why I'm using sum plus equal to node value. After that, if node dot left is not equal to null, means what I will do whenever I do a traversing, I will traverse. I will go to the first means left side and right side. What I will see is it should not be empty to insert the element inside it. So what I have done is if the element is not empty at the left side means, so what I will do is simply add it. Q dot add is node dot left. After that, what I will do is node dot right means I will go to the right side. After that, I will simply add it, and after that I will just add the sum at each level, that is al dot add sum. Okay. After that, what I have done is collection dot sort al. I have done the sorting of the elements because I have already told you whenever I want to find the sum means the kth largest sum, I always need to be sorted down, because if I will sort now, I will get the largest sum. Okay, that's why I'm using collection dot sort in Java. After that, yes, I will simply see L dot size greater than equal to k. What does it mean of greater than equal to k? Greater than means I need to find the sum of the third largest element. But in the array we have find out only 2 elements exist. So do we can find out the sum? No, we can't find it. In that case, this return -1 that is given to us. Otherwise, if it is greater than equal to k, so what I will do, return al dot get. Al dot get. Get means in we need to find get actual value. Get that actual value. That's why I use al dot get. Otherwise, what is written? Al dot size minus k. What does L dot size minus k, that I have already told you. Whenever we need to traverse now, we need to find the element, the sum from the last. Whenever we need to find the sum from the last now, so what I will do, the L dot size means the size of the array we have taken. After that, just subtract the value minus k. K means just replicating the index. If we want to find the index, means we want to find element from the index, and also we need to find from the last side, means from the end. That's why I'm using L dot size minus k. And simply return after, if this function does not satisfy, just return the -1. Okay. If you want me to send to share it with you with all the comments, so you can better understand the code, this is the simplest code I have ever seen. If you want me to share it, just comment it down. I will definitely reply you. Thank you. I hope आप लोगों को समझ आया होगा.